When we write functions, we generally have, f of x equals some nice rule in terms of x. And that's not always super realistic as far as real world problems. Very often, when a quantity depends on another, there are a lot of different things going into play that can determine how they're related. And this leads us to a special type of function called a piecewise function. And a piecewise function is a function where the rule actually depends on what our input is, where our input is in our domain. So in other words, it might be defined one way for negative numbers and a different way for positive numbers. Or it might be defined one way for numbers less than 100 and another way for numbers greater than 100, okay? And this is how we write them. We have f of x equals, and then we have this curly brace, and then we write our different rules, and these are like the formulas, okay? And then a comma, and then we say what the rule is for x, like what values of x do we use that rule for, okay? Let's go ahead and look at an example. Consider this function f of x equals this thing. This says that when x is less than 0, in other words, when it's negative, our rule is going to be 2 times x plus 1. Okay? When x is greater than or equal to 0, our rule will be 1 minus x. So we're going to go and sketch this function. Now we know how to sketch both 2x plus 1 and 1 minus x. Those are just lines. Okay? So if we were to think about, say, y equals 2x plus 1, that's a line with a y-intercept of 1 and a slope of 2. So I could draw that whole function, and that's certainly doable, right? However, we are only using that function when x is less than 0. In other words, we're not going to use the right side of this graph. When x is greater than 0, over here to the right, we don't have this line. So we're going to go ahead and get rid of that. Okay? And in fact, when x is equal to 0, we don't use that either. So to be very precise, we should put a little hole right there to indicate it's not, okay? So that right there is the graph of this first portion. This second line, we've got 1 minus x. Well, if we think about what y equals 1 minus x would be like, that's a line. Let's rewrite it as negative x plus 1. That's a line with a y-intercept of 1. Okay, so I do get that point. And a slope of negative 1. Well, a slope of negative 1 would look something like that. Okay, and again, the line itself would go all the way. However, I'm only using that line when x is greater than or equal to 0. So I don't actually have this left portion of the line. Okay, so this line right here, that's the 2x plus 1, and this right here is the 1 minus x. So that's a sketch of this piecewise function. Hopefully you can see now why it's called piecewise. It's got two different pieces to the graph. For evaluation, find f of negative 2. Well, negative 2, you look at your input and say, well, where does that fall in our domain? Negative 2 is less than 0. So we're going to use this rule to evaluate it, 2x plus 1. This is 2 times negative 2 plus 1. That's negative 4 plus 1, which is negative 3. For f of 3, well, 3, this input, that's greater than 0. So we're going to use the second rule. So that's 1 minus x, which is 3. 1 minus 3 is negative 2.